In this video, we are going to talk about solving logarithmic equations. So having equal signs in our equations instead of just manipulating an expression. So let's take a look here. I'm going to show you kind of two different ways. One is to go and rewrite in exponential form. Okay, so that's when you remember that you'll take this base 4 and then flop the input and output. So 4 to the 5th equals x. That's rewriting it in exponential form. And then you could just evaluate that in your calculator if you wanted to take that further. So over here, this one has a base 10 when it's not written. So if we were going to do this one, it would be 10 to the negative 5 equals x. And then again, you could evaluate that if you wanted or if the problem asked for it. So that's one way on these kind of simpler ones with just one log. However, some people like to really keep in line with what you've been doing in math, basically for your whole math career, which is doing something to both sides, right? Adding something to both sides, dividing something to both sides, whatever that may be. So in which case, and you always do the inverse. So if you have a -4 and you're going to undo that, you're probably going to add 4 to both sides, okay? Or if you had to multiply by 3, then you're going to divide 3. So you're always doing the inverse operation. So thinking about logarithms, the inverse operation of a logarithm is an exponential function, okay? So if we're trying to get rid of a log, we want there to be an exponential function. So in order to get rid of the log, you do what's called exponentiating both sides. So you bring it to a base of 4. So we'll put a 4 down below. So this is 4 to the power log base 4 of x, and then 4 to the power of 5. Okay, so these are now exponents. You just put a 4 underneath them. Because then what happens is the exponential base 4 and the log base 4 cancel. So on this side, you're left with x. And then on this side, you're left with 4 to the 5th. Which again, if you remember, is the same as what we got writing it in exponential form. So similarly over here, remember that the base here is 10. So we're going to exponentiate both sides or put a 10 below so that these move up into the exponent. So then the base 10 exponent and the log base 10 will cancel. You're left with x equals 10 to the negative 5th. Okay, so if you forget how to write it in exponential form, you can always do that. All right, then they can get more complicated, but we still only have one logarithm in here, okay? We don't have multiple logarithms. We just have this one. It's a base 10. Remember that when it's not written. So what we need to do is isolate this. So if I kind of simplified this over to the other side, this is almost like 1/2 times something we don't know minus 1 equals 0. This being the something we don't know. Okay, so this whole thing being the something we don't know. So simplified, it looks like this. Okay, so if you were going to simplify, if you were going to solve this equation to get this unknown by itself, you would add 1 and then divide by 1/2 or multiply by 2. So that's going to be the same thing that we're going to do here. So we're going to isolate this log first. Okay, by adding 1 to both sides. So we have 1/2 log of x plus 7 equals 1. Okay, to get rid of that 1/2, we're going to multiply by 2 to both sides. So you'll end up with log of x plus 7 equals 2. Again, if you remember how to write it in exponential form, you're welcome to go straight to that. Okay, otherwise you're going to exponentiate both sides. So put a 10 below each side, pushing those up into the exponent. So then the base 10 and the log base 10 will cancel. So you're left with x plus 7 equals 10 squared, or 100. So then you can subtract 7 to both sides and get 93. So again, at this step, if you remember how to just write it in exponential form, right? So you would get 10 to the second equals x plus 7, and you'll end up the same. 100 subtract 7. All right, then if we look at this one, we have multiple logs. Okay, so we have 3 logs in this whole thing. So when you take a look at this, you can actually condense this using the rules that we learned for condensing and expanding logarithms, because you've got the same base here. Okay, so you've got a base 10 all the way across here. So what we want to do is, if we can get a log of the entire side, that's good. So this has log of that whole side, so log of 4x here. Then over here, we can put these together by putting the insides multiplied by each other, right? Because we've got this plus here. So 5 times the x minus 3 on the inside there. And feel free to simplify that. So having log of 5x minus 15. So now what happens is you have the same log on both sides. So if we have log base this equals log base that, okay, then the this and the that need to be the same, right? Okay, so you would just set these equal to each other. So you'd have the insides equal to each other. So 4x then has to equal 5x minus 15. You can also think of it, if you forget that, you can think of it as exponentiating again. So putting a 10 below here and pushing these up into the exponent, because then the base 10 and the log base 10 will cancel on both sides, and you'll just end up with the 4x equals 5x minus 15. So then subtract 5x from both sides. So you'll be at negative 1x equals negative 15. Divide by negative 1, and you'll end up with x equals 15. So this one, again, has multiple logs. However, notice that this term right here does not have a logarithm with it. Okay, so we've got 2 log base 15s, but we also have one term that doesn't have a log. So we can't actually get this side together because this doesn't have a logarithm. So what we're going to want to do is bring this one over to the other side so that it's with the other log base 15. So we're just going to add log base 15 of x to both sides. Okay, now you can't just add these together. Okay, so you're going to have to use a rule to get those together. So you're just going to write log base 15 of x plus 30 plus log base 15 of x, okay, equals 3. Then remember, the way you bring logarithms together is by multiplying their insides, okay? So we're going to have log base 15 of x times x plus 30 equals 3. So that will get those logarithms into 1. And I mean, obviously you can simplify this inside. So x squared plus 30x. So now we're going to want to get rid of that logarithm. So again, you can just rewrite it in exponential form. You can also exponentiate both sides. So then you end up with x squared plus 30x equals 15 to the third power. That does not look like a power. All right, 15 to the third power, which you'll then need to evaluate. So x squared plus 30x equals, and then do 15 to the third power. So 15 times 15 times 15, and you'll get 3375. So subtract that over so that you can factor. So then find factors of negative 3375 that add to 30. Okay, so that's going to be 75 and 45. You want it to be a positive 30. So you're going to want a positive 75 and a negative 45. Split these up and solve. So x plus 75 equals 0. X minus 45 equals 0. Okay, so x equals negative 75 or x equals 45. Now, you want to check and make sure that you don't have an extraneous solution here, okay? So we had negative 75 and positive 45. So if you remember back to what the graph of a logarithm looks like, okay, it looks like this. Because you can't have any negative inputs, okay? So you can't, when you do the log of a number, this number has to be greater than 0. Okay, so you can't plug in a number less than 0 here. So we need to look at our original equation here and make sure that we're not going to have any less than 0 when we plug in. Well, when you plug negative 75 in here, that's going to give you a negative inside the logarithm. So that's bad. Okay, so that's an extraneous solution. If you plug in 45, 45 plus 30 is 75, that's fine. And when you plug it in here, that's fine. Okay, so x equals 45 is your only solution here. All right, then let's take a look at a couple that have natural logs, okay, so that you remember that the base of a natural log is e. Okay, so if you're going to write this in exponential form, make sure you remember that the base is an e. So if you're doing something to both sides, remember that you'd be putting an e to both sides, so exponentiating it, shoving those up into the exponent so that those cancel, and you're left with x equals e to the 6th power. And with an e, unless your problem asks you to do it in decimal form, I would just leave it like this. All right, and when we're using logarithms, you do not want radicals in them because logarithms have to do with exponents. So instead of having it in radical form, we want it in exponent form. So I would rewrite this square root right away to a 1/2 power, because then you can use the power rule to bring it out front. Then you can multiply both sides by 2 to get rid of it, so that you isolate that natural log. So 8 times 2 is 16. Again, remember that that has a base e there. Okay, so then you can exponentiate both sides, pushing that into the exponent so that that will cancel. And you end up with x plus 8 equals e to the 16th power. Subtract 8 from both sides. So you have e to the 16th minus 8. You can put that in your calculator and get a decimal. I just don't feel like it. So we just have e to the 16th minus 8 as our final answer.